Hello and welcome to Physics 2212 Lab 1 Charge Tapes. My name is Baugher and I'm going to walk you through what I did for this lab. To begin, we need some necessary background information. To clarify, the purpose of this lab is to prepare charged pieces of tape, observe their interactions, and approximate the excess charge on one piece of charged tape. By creating a model like the one seen on the right, we can calculate excess charge on the tape using the equations for electric force and gravitational force. The equation for the electric force is the charge of A times the electric field of B, where the electric field of B is 1 over 4 pi epsilon naught times the charge of B over the distance between A and B squared times r hat. The gravitational force is equal to the mass of B times gravity. Here, constants will be specified as K equals 1 over 4 pi epsilon naught, E, which is the charge of a proton and electron, is 1.6 times 10 to the negative 19, and G is 9.81. Now let's take a look at our experimental model. First, we need to find the charge of the tape. I took note of the length and mass of the tape, and then, knowing that plastic pens, when rubbed against hair, have a negative charge, we can determine the charge of the tape by charging it and holding it up to a negatively charged plastic pen. If the tape is attracted to the negative plastic pen, then we know that it must be positive, but if it is repelled, then they must be negative. Then we took two charge tapes and held them up against each other, and we found that they repelled each other to confirm that the tape has a positive charge. Now we can set up the main experiment using tape B as our system and everything else as the surroundings. After running the experiment, I needed to measure D, the distance between tape A and tape B when B was floating above the surface of tape A. From this free body diagram, we can see that the electric force is pointing in the y-hat direction and opposite of the gravitational force. This means we can deduce that they must be equal in magnitude. Knowing that they are equal, we can run calculations to find the excess charge of A on tape B. Now let's look at a computational model. First, we had to make the assumptions that we needed to treat the tape as if it were a point charge with all the charge concentrated at the center of the long tape. From this, I created 2 point charges and found the gravitational force on point charge B, or the blue charge, and the electric force from the orange particle on the blue particle. We can see that they are equal and opposite in magnitude. However, we can now calculate the excess charge from the electric force. Now let's discuss. What if electrons had a positive charge and protons had a negative charge? Well, in this case, our model would not change, as the force of gravity would still remain in the negative y-hat direction regardless of charge, and the electric force between the two would still repel, considering that the charged tape would now both be negative. Now, why is it important to handle the charged tapes as little as possible? Whenever you touch anything charged, you can cause the electric field of the tape to interact with surrounding electric fields, and this could affect our results by changing the magnitude of our electric field and making it less in magnitude or revert back to neutral. Possible sources of error from this experiment include the tapes aren't exactly point charges, plus there are multiple present electric fields at any given moment that may not be accounted for in this experiment, along with the fact that the distance between the two tapes is not precise nor accurate reading.